So let's look now at a couple more examples of how we can use the map as part of the same data set that Scott was showing us in the lab code. So the fact that we have localization onto the map, we know exactly which lane the vehicle is occupying, and because the map is semantic, we can then derive all of the information that is relevant to this lane. In particular, we know where the car is allowed to merge and where it cannot merge. So for example, to the left here we have a median, and we know that we can't go over that, but to the right we have a dashed white marking, and we know which one of the neighboring lanes is the one immediately to my right that I can merge into. Like we've been showing with the signals, we can do the same thing with signs, and we can give the car selective attention. And also, since we know the classification of each one of the signs, we can tell the car which ones are safe to ignore right now and which ones are more important. There are different trigger points along a lane where someone can take action, or an autonomous system can take action. And in this case, we have a lane departure here from the lane that we're occupying onto a left turn only lane. And then we provide not only a trigger point, but a potential trajectory from one of the lanes to the next. And then while we're stopping at the intersection, we've only highlighted the signal which is relevant for the lane that we're occupying. And therefore, if we just want to understand, if we want to understand if the state of the signal is red or green, then we don't really have to analyze the entire scene, figure out which one is the signal that we're looking for. We can just look inside the cropped bounding box. Similar example, when we have a pedestrian crossing, we can also direct the attention of a camera, or even tell the radar sensor that this is an area where we have a higher likelihood of getting pedestrians, so be very wary of false negatives in this particular region. So we have those hotspots that we can identify. Further along in the data set that we have, there are different instances where part of the infrastructure can be hidden. In this particular case, we have a truck that is hiding the signal on the left-hand side. And we can argue that, yes, there is another signal on the right-hand side, but this is just to showcase that there will be points in time where there is an important asset for us to pay attention to, which is hidden behind another object, and where we may only get 1 or 2 camera frames to analyze and figure out what is the state of that particular asset. So the map can also give us that information, which is hidden behind different dynamic objects in real time. Before concluding, I will also say that we're hiring, so make sure you go onto our website, check out the open positions, apply, and if you don't find your position, just email us anyways, and if there's a good match, we will be happy to have you join our team. We are growing in this office and in other offices as well. Thank you very much for joining this webinar. I see another question from Tom here that I will try to answer. So, how accurately can you localize with LiDAR versus stereo? That's a good question. This is something that we're evaluating currently. In the LiDAR space, we are within 10 centimeters of the correct position in X, Y, and Z, and within half a degree in omega phi and kappa, and we have actual numbers on our performance under different scenarios. For stereo, we don't have as much detail on that. We have shown stereo-based localization. It is comparable to LiDAR, I would say, in this case, but the issues with stereo are primarily on the sensor side of things, so the disparity maps are not as clean as we would like them to be. We also have a reduced match rate. So as you know, what we do for localization is we create signatures from the environment, in our reference trips, and then when we're going back through the same area, then we are matching the real-time signatures to the existing ones. With stereo, we get a noisier point cloud, and therefore we have a reduced match rate because of that. So our confidence in localization is a little lower as well on the stereo side. The accuracy is not as much sacrificed, however, because we still get matches. So the accuracy should be comparable, but the confidence will be slightly lower. This is how I would address this question.